Now suppose we're looking at this limit. So the limit as x approaches infinity of sine x over x minus pi. Keep in mind that before you just hit these limits with L'Hopital's rule, you should always check the form. And so the denominator here, infinity minus pi, sure, the pi becomes negligible as x gets very, very large, and so this denominator is approaching infinity. Now the numerator, if you remember your graph of y equals sine of x, it looks like this. So it's this wave, function with a range from -1 to 1. As x approaches infinity, sine of x isn't approaching anything. The limit as x approaches infinity of sine of x does not exist due to oscillating behavior. So we can't say that this limit up here has the form infinity over infinity because, I don't know, this isn't really a form, but what I would say is this is the limit of the numerator does not exist. So we're not going to be able to use L'Hopital's rule. So it's going to be helpful for you to remember your Cal 1 techniques for dealing with limits. Let's get rid of this so I have room. So the way to attack this limit is using squeeze theorem. So the idea with squeeze theorem is if we can trap this expression here between two other expressions whose limit agrees, the limit as x approaches infinity on these two outer functions agree, they're both approaching the same finite number, then the limit of this expression stuck in the middle will have to approach that same value. We use the squeeze theorem a lot with sine and cosine functions because they're easy to trap, because if you look at this graph, we can trap sine of x between -1 and 1. Well, okay, but that's not quite what we have. What we have is sine x over x minus pi. But so I could divide all three parts of this inequality by x minus pi. The one thing to be careful of when you divide across inequalities is make sure you're dividing by a positive number. Because if you remember you divide by a negative, that will reverse the inequality. But if we're talking about x approaches infinity, then we can assume that x minus pi is a positive number. And so if we consider the limits of these outer functions, the limit as x approaches infinity of -1 over x minus pi, well, that's got the form some finite number over infinity, and so that limit is going to 0. Similarly, the limit as x approaches infinity of +1 over x minus pi also has the form some number over infinity. So that's also going to 0. Since this limit's approaching, this expression is approaching 0, this expression is approaching 0, then the limit of the function trapped in between, this must also approach 0. And so the value of this limit right here is 0 by the squeeze theorem.